Okay, so second one on trig. We need to know values. There's certain triangles that are important. They come up a lot. So the first one has got angles 90, look, 30 and 60. So the angles are in the ratio of 1 to 2 to 3, 30, 60, 90. And the sides have got a 1, a 2 and a 3 in it. But this side has got to be root 3, so Pythag works. Square this one, we get 3. Square this one, we get 1. Add them up, we get 2. And 2 squared is 4. So from this, we can see that sine 30 is equal to opposite over hype. That's a half. And cos of 60, adjacent to 60 is side 1. And hypotenuse is 2. So that's equal to cos of 60. And sine of 60. There's 60. Opposite is root 3. Hypotenuse is 2. So that's root 3 over 2. And that's the same as, well, 30 degrees. The adjacent side is root 3. Hypotenuse is 2. So this is the same as cos 30. Tan of 30 is opposite over adjacent. So tan of 30 is equal to 1 over root 3. And tan of 60, opposite to 60 is root 3, divided by 1. So tan of 60 is equal to root 3. Second triangle is an isosceles right angle triangle. And the easiest sides we can do that are the same is 1, 1. Square 1, square 1. Add them up and get 2. Square root it. The angle, because these two must always add up to 40, these two are 45 each, so they must always add up to 90. So cos of 45, if we take that 45, adjacent is 1, hypotenuse is root 2, and there's a 45, opposite is 1 as well, divided by root 2, so sine of 45 is also 1 over root 2, and tan of 45 is the easy opposite over adjacent. 1 divided by 1 is 1. You might want to know, so these are the important two, you might want to know, because it happens a lot, the 3, 4, 5 triangle. And the small side, opposite small angle, small side, small angle, 36.8699, and this one is 53.1301. So they add 4 decimal places in degrees, so they add up to 90. And we've got cos of 36.8699 is the same as sine of 53.1301, and that's equal to adjacent over hype is 4 over 5 for this angle, because sine of that one is 4 over 5, so 4/5 or 0.8 if you want, and cos 53.1301 is equal to sine of 36.8699, and that's equal to, so cos of this one, adjacent side is 3, hypotenuse is 5, sine of 36.8699, opposite is 3, hypotenuse is 5, so that's 0.6, and tan of 36.8699 is equal to 3/4, opposite over adj for that angle, and the other way around, tan 53.1301 is equal to 4 over 3. This is obviously 0.75 if you want, and we don't bother writing 1.3 recurrent for this. Okay, so based on these, we can draw a table in a minute, but we need to have a look at some graphs first. But before we have a look at the graphs, there are a couple of interesting things that we start to see from things like this. That I'm going to draw another triangle. Yeah, there's my graphs coming up. Look. One more triangle, general. If this has got, let's see, this is 1, this is an angle theta. If that's 90, this angle up here is 90 minus theta. So the adjacent side to theta must be the cos of theta, we saw that before, it was x, and we replaced it by cos theta because x over 1 is the cos of angle, and y on this side is the sine of theta. We'll do that. Y and x, this is equal to sine of theta based on theta, because y over 1 is op over hype for sine of theta, and x over 1 is equal to cos of theta, because cos is adj over hype. But x over 1 is also the opposite to 90 minus theta. So sine, cos of theta is the same as 90 minus theta, and the sine of theta is the same as cos of 90 minus theta. And x over y is equal to x over y, adjacent over opposite, or x over y. X is opposite to that one, so that's tan of 90 minus theta, and that's equal to 1 over tan of theta, which is equal to 1 over x over y. So that means that y over x, which is 1 over this one, is equal to tan of theta. So for example, tan of 40 is the same as 1 over tan of 50. Sine of 36 is equal to cos of 54, and we can get a calculator out and test that. Tan of 40 equals 0.8390999, 1 divided by tan of 50 is the same. Sine of 36 is equal to 58778 and a few more bits, and cos of 54, oh look, it's the same. Get the idea? So we can see these identities and these and this identity here. Okay, so what happens next? Well, we're going to have a look at a graph. This one. It's the same graph, we'll just put the points in different positions. So what I've got is a unit circle. Look, it's got a center at 0, and this point is 1, that point is 1, this point is 1, that one is 1. I've got different views of the same circle, and all I'm doing is starting with the positive quadrant, and I'm saying an angle of 28.07. The xy coordinate I'm going to replace as, because my hypotenuse is 1, because it's a radius of my unit circle, because my radius is 1, then the x coordinate, the distance, the horizontal distance to this point here, look, that side of my right angle triangle is the same as cos of theta, because we saw that on those other triangles before. And it turns out that 0.88, I'm not sure if you can see that, it's written really tiny, 0.88 is the cos of 28.07, so the x coordinate is the cos of theta, and the y coordinate is the sine of theta, which the sine of 28.07 says is 0.47. We tend to measure, as we go around the unit circle, we start at 1 0 and we go around anti-clockwise. Don't ask me why, it's just the convention, that's what we do. And so that's a nice little triangle over there that we used to see in the right angle over there. But what happens if we get an angle bigger than 90 degrees? Well, the x coordinate is still the cos of the angle that we've made from the point B. So as we go around there and we have a triangle like this, that's not a right angle anymore, it doesn't really matter because we've got a right angle over here. But we measure the angle from B. So the cos of 139.23, cos 139.23 is minus 0.757, and they rounded it to minus 0.76. So that's the x coordinate over here, and the y coordinate is still positive because we're still above the x-axis. So sine of 139.23 is equal to 0.653. And that's what it says there. And then we go around a bit further. So we've not got an obtuse angle anymore, we've got a reflex one. And we're in this quadrant down here, look. The x coordinate is still negative. So the cos of 241.79 is minus 0.47. That's how far we've got, nearly to a half, but not quite. And the y coordinate has gone negative because we're below the x-axis. So this coordinate is minus 0.47 minus 0.8, whatever it is, nearly minus 0.9. And then we come around to the fourth quadrant, both negative. The x and the y coordinate are both negative. And we've got a really reflex angle, 339 or something like that. And when we cos that, we get positive because we're to the right hand side of the y-axis, and the x coordinate is negative. So cos of really reflex angle bigger than 270, less than 360 is pos, because the x value is over there, look, and the y coordinate is neg. So the sine of really reflex is still neg. So if we start at angle small and traverse our circle and follow the x coordinate, then we're going to trace out the cos graph, which looks like, I made one earlier. Where's it gone? There it is. So the blue one is the cos graph. So as we start, there's our circle up. So as we start on the right hand side and go around that way, so x starts at 1 and comes down as we go around there. So we've got an angle, we have 28.07. The x coordinate is slightly less than 1, so 0.88 is about there with an angle of 20, well that's 90, 30 is about here, so 20 and a bit, there you go, because the graph is 0.8. Go a little bit further and the x coordinate gets a little bit less as the angle gets a little bit bigger. The angle gets bigger again to about there, and the x coordinate gets a little bit smaller, and then we go up here, so the angle's got bigger, look, the x coordinate has got smaller, so the angle is nearly 90, that's 90 there, so the angle is nearly 90, and the y value represents the cos of the angle, the y value on this graph, but we're thinking about the x coordinate on this one. So what we're doing is changing theta, and we're thinking about our x coordinate, yeah, on our unit circle. And as we get to obtuse, then the x coordinate gets negative. So we've gone from there, we've gone all the way around to this point, and the x coordinate is over here somewhere and negative. So we start getting a bit negative until we get all the way over here to 180, at which point we're the furthest left we can get, which is -1, look. And then we stay negative, the x coordinate is negative, look, for that triangle. And then we go all the way around here, so the x coordinate's got less negative. Let's go around here, we get less negative again, I think it gets bigger until we get around to 270, and we're back on the y-axis, so we're back at 0. The x coordinate of this point is nothing, and then as we get around to there, so we go back up to 1, look, and we're positive again as soon as we've gone past 270. So there's our cos graph. And if we do the same thing with the y coordinate, so we plot the y coordinate is equal to the sine of theta. I'm saying that's my theta angle there. Let's do it on this graph. So as I start small, down here somewhere, so the sine of angle is this height. There's my angle. So sine of small is small, and as I get a little bit bigger angle, so my height of this triangle gets bigger. Height of triangle quite a bit bigger because the angle's a bit bigger. So we're as big as possible when the angle has gone round to 90 degrees. And as we get bigger than 90, we go obtuse, so we start coming down again. So if I draw that triangle there, this is my angle, remember, from B, anti-clockwise, so bigger than 90, about 110-ish. Then the y value on this graph represents the y value on this graph, and this axis here is measuring how far we've turned, and we start coming down. We're less than 1 at 110-ish, and then we get a little bit smaller when the angle is bigger, and we get really quite small when the angle is close to 180, which is this value here, round to 270, this quadrant. The height of the triangle is negative, height of the triangle is more negative, lots negative, big negative, and so we get down to -1 at 270. We turn round 3/4 of our circle, and when we start coming back, we start getting back up to 0 again. So that's what's happening here. And the tan graph, I'll let you find out that for yourself, but essentially if we draw, let's do one of these other ones that I've not used yet. So if I draw a tangent to the circle at x equals 1 and draw an angle here, there's my length 1. If I continue that radius until I hit the x equals 1 line, the tan value is this one here, because the tan of theta, this length is 1 look. So tan of angle is op over adj is tan of theta over 1, which is just tan of theta. So as I get bigger, so my tan angle gets bigger until I get huge. The tan angle is very large. The tan angle is huge, huge, huge. Goes off the page until we're at 90, and then it's not defined. So that's why we get 90 degrees here, we get an asymptote. 90 degrees here, we get an asymptote. So at 45 degrees, we're at 1. That's 1 there. Alright, so this is the weird looking tan graph. And it's the position that we're at if we extend the radius of our unit circle to the line x equals 1.